So in this video, we're going to use the definition of a derivative to show where the derivative of the cosine function comes from. So the claim is that the derivative d theta of the cosine of theta is equal to the opposite of the sine of theta. So if you were trying to come up with the derivative of the cosine function from scratch, you would need to use the definition of the derivative, which is take the limit as h goes to 0 of the difference quotient. So to find the derivative of the cosine of x, we take d dx of cosine x is take the limit as h goes to 0 of the difference quotient applied to the cosine function. So we get cosine of x plus h minus cosine of x all over h. And just like in the previous video when we were working with the sine function, we want to recognize that we have a sum identity for the cosine function from trigonometry that will let us break this piece up into more granular pieces. So the cosine of x plus h from trigonometry is going to be the cosine of x times the cosine of h minus the sine of x times the sine of h. So first step is just break that apart, break the cosine of x plus h apart using that trigonometric identity from pre-calculus. The next step is to look at the pieces in the numerator and see if anything looks useful. So for example, the limit as h goes to 0 of sine h over h from video 1 in this homework is going to be equal to 1. So that looks like a useful piece to break off separately. And then I want to notice that the cosine of x shows up twice, once here and once here, and that's something that could allow me to factor a cosine off. So the next step would just be to factor it into those pieces. Group the minus cosine x with this cosine so factorization can happen, and separate out the sine h over h piece. So on the next line, that's what we've done. Here's the minus sign right here, pulling down into this position, separating the sine x sine h over h off as a piece, and then grouping the cosine x cosine h minus the cosine of x into two pieces. So again, I still see I have that limit as h goes to 0 equaling 1 showing up here. And this, what I want to notice is if I factor off a minus the cosine of x, I'll have a 1 minus the cosine of h over h showing up, which from video 2 is a limit as h goes to 0 that will equal 0. So we want to factor a minus the cosine off of this. So when we factor the minus cosine off from these two terms, it's going to leave us a 1 minus cosine h over h. I have my minus sine x. I'm pulling this out from the h so that I separate that limit that's equal to 1. And now I can just calculate the limits of the terms. So kind of shortcutting, which you can start to do as you get more comfortable with taking limits. I want to notice that the limit as h goes to 0 of minus the cosine is just minus the cosine. The limit as h goes to 0 of 1 minus the cosine of h over h from video 2 is just equal to 0. So I have a limit of a product equaling the product of the limits. And then minus, the minus coming down to here. The limit as h goes to 0 of the sine function is just the sine function. And the limit as h goes to 0 of sine h over h is just 1. And that just simplifies to 0 minus sine x is negative sine x. So that establishes that the derivative of the cosine is the opposite of the sine function.